Yes. Okay. Assalamualaikum warahmatullahi wabarakatuh, and a very, very good evening, early evening to all of you. All right, I would like to share, some information here from my, if I can share here. All right. Okay, I'm sharing you the my presentation. Okay, do you see my presentation? All right. You see here? Can I get a feedback? Yes, all right. All right, so this is my, thank you Dr. Zarina, thank you Dr. Yi for inviting me in this session, all right. So I'm sharing you about the research methodology for numerical analysis for MSCM 1033, MSCI, CI ke CJ ni, okay, 1033 CJ, yeah. USCP 0010, right, for our student, masters and PhD in numerical, and of course, okay, Faculty of Science, Mathematical Science Department. Okay, I'm Associate Professor Dr. Nurma Alias, okay, from Mathematical Sciences Department, Faculty of Science, University Technology Malaysia. All right, today we meet because we want to share with you what is the aspect of numerical analysis in doing research, especially for masters and PhD student. All right, so now let's we go to the content. Okay, you can see here the content table. I would like to share with you what is the numerical analysis in the research with the masters and PhD student, what is the application. And then I try to make a difference between doing masters and PhD in numerical analysis and a fundamental numerical, what we call as a fundamental numerical, the numerical method and scheme. Okay, they're different with others. We have the computational platform, and then we have the indicator to measure the model, the method, the scheme, and the performance of our algorithm. And some research proposal, example on writing the research journal, research thesis, or papers, or the technical report, and research publication where we need to publish, and some conclusion. All right. So now, before we start, I love, Dr. Yi, I know this is your cupboard, I know, all right, because you are very systematic thinking, all right, understanding what's different part, what the element, different dress or trousers or shoes in your cupboard, am I right? So we try to guide you to be a systematic thinking, all right, especially, how you arrange, things in your cupboard. All right. And then I love if I can share with you. Okay. If I can share with you early in the morning, some testing. Okay. You read the color, not read the words. Okay. Can you read the color? Okay. How much, spend for reading the colors? For example, okay, we read as a green, red, blue, yellow, blue, black. So we try to transform the words to the colors. Can you do it? Okay, I give you a few seconds. Okay, try to say colors. Okay, because then don't say the words. Don't say the words. Okay, can you do it fastest, Dr. Yi, Dr. Zarina? Can you do it? All right. Okay, so. All right, so what you do now is you are in conflicts whether using left brain or right brain, because your right brain tell to say colors, your left brain try to say the words, because left is more logic, right is more abstract. All right, so that's why there is another terminology we call center of the brain, where there is a balance between left and right. All right, never mind. Okay, thank you very much. Oh lah, susah kan, susah lah. Okay. So now this is the time for us, okay, to try focus on the left brain. The same time, okay, we need a right brain for the methodology, imagination, okay, your research track and so on. All right, so now that's we want to do, okay, we need both parts, okay, we need both parts. All right, so in doing research, okay, of course, okay, this first step, you need to have a proposal. Okay, it's very tough for you because sometimes you want to, okay, change your field, whether numerical, statistic, OR, okay, pure maths. Okay, that's you need to make sure, okay, you go from your conflicts. Okay, so now since you are choose numerical analysis, okay, numerical method, numerical, okay, computational and so on, so it's be done. So you need to have the experiment, and then whether there is a flexible or not flexible, okay, you do some research. This is a process. All right, so revise the proposal again because sometimes, all right, you fail to finish a certain, okay, what you want to aims, what you want to do as a main objective. All right, revise a proposal again, and then start, okay, focus, and you doing your experiment, doing the analysis. All right, get a sufficient result, convincing, and then write a paper and give a talk. All right, so that's we try to guide you. All right, so now, okay, in doing this, okay, I love if I can start with the, okay, data. Okay, because I know you're dealing with the mathematical modeling, you're dealing with the what we call method, you are dealing with the computational, okay, computational cost, computational complexity, you're dealing with the image. Okay, so how numerical, okay, can solve your problem. All right, so we call this one is a quantitative research method. Okay, emphasize on the objective measurement. Okay, like before you are using statistic, mathematical modeling, and then now, okay, you're using numerical analysis to interpret the data collected, okay, through the pool. Okay, I love if I can share with you, okay, okay, if I can share with you, okay, some, I'm stop sharing, okay, what the data type, okay, what the data type that you are going to focus here, okay, all right. So this is a data type, okay, there are so many types of data, there is images, okay, you can see here, okay. There is images. I'm using images. There are many types of images. Some of them is a data from the company, personal data. Okay, you got the data from the questionnaire. It's very easy to get feedback from the customer, from your client, because from the participant, because nowadays we are dealing with the online, okay, questionnaire using online Google form, okay, or SurveyMonkey. You see, there are so many data, and how you want to do a feature extraction or dimensionally reduction based on the data given. So many data, all right, so many parameters involved. So this is a question. And then, of course, in numerical, we need to have the integrated between the data, all right? I'm using, many software here, all right? For example, I'm using Geo Information System, GIS, to get the data, okay, from Google Earth, Google Map, and then abstract the data using the what we call as GIS, okay, SNAP or GSC, to get the contour for the specific region. All right, so and then we analyze using numerical, or we are using machine learning, all right, to make sure that what we predict, okay, and then is accurate and converge to the approximation solution at the industry, for example. All right, so I'm stop sharing. I go to the next, okay. All right, so the issue here, okay, how to analyze the data. So this is an issue, okay, how to analyze the data. Okay, there are so many processes to analyze the data. Okay, for example, okay, you can see here, okay, if I can, okay, go to here. All right, so now there are so many ways, okay, some of them using mathematics, some of them using statistics, some of them using, okay, convert to the mathematical modeling. But in research analysis, okay, what should you do? Okay, since we have the real application, okay, I just give you the images, for example here, all right? Okay, what we do in basic, okay, numerical is, okay, we try to model using ordinary differential equation or partial differential equation or any mathematical modeling related to the application. All right. So in numerical, okay, the traditional, okay, we discretize the method using finite volume, finite difference, finite element method, okay, or other integration, or you can use the, okay, curve fitting and so on. The way how to discretize, how to convert from the images to the point, to the nodes, to the grid. All right, and then the next is you apply the theoretical numerical analysis in this thing. Okay, you are using, okay, how the stability, how the consistency, how the convergence, okay, of the method. Okay, when you do the solution for finite difference method or finite element method or finite volume method. All right. So in this case, okay, you are, okay, trying to get the important parameter, the important characteristic, okay, based on the data that you transform from the what we call signal data to the digital data. All right, and then this is a core business. Okay, what is your core business? Is developing the methods, developing the scheme, developing a technique of the numerical. Okay, the example, okay, for the basic is a Gauss-Seidel, Jacobi, group explicit, okay, alternating group explicit, all right, and then semi-explicit, and then the technique that you can solve using sequential, parallel, and so on. All right. So the computational aspect in this case, okay, because we're dealing with the numerical, okay, of course, we need to have a tool. We have a platform, software, hardware, and so on. All right. And then, okay, when we do the validation and verification, okay, just now I give you images that is a industrial, okay, I got from the data from the hospital, from the industry, from the GIS, and so on. So we do the laboratory scale. In our case, maybe you can do a dimensionalized, okay, or controllability, okay, approach to make it more laboratory scale. All right. So now, okay, and then second is performance. Okay, performance. Okay, there are so many performance involved in numerical. Okay, of course, just now I just mentioned about the, okay, computational cost, convergence, stability, consistency. All right, so this is a performance measurement. The same time, okay, since you are using other field, for example, machine learning, okay, images and so on, there is another, okay, measurement indicator. For example, if I'm using machine learning, I need to use, okay, sensitivity, preciseness, okay, and then convergence and so on. All right. So now this is a trend, okay, with the numerical result, with the numerical analysis, what you are doing, okay, you are able to visual the problem. You are able to, okay, focus on the result, and then you compare with the solution from the differential equation, and then the real application. All right. So of course, the next is a trend and the region of your research. Okay, this is your future research. All right. So now, okay, how to do this? Okay, how to do all the process? Since we know that numerical, okay, is a focuses on the, so we know that numerical is a focuses on the numerical data generalized across the research to explain a particular phenomena. Okay, there are so many applications nowadays, okay, and then we can apply all the theories, okay, that we developed before, and then, okay, we go to the theoretical numerical analysis. Okay, we go to the theoretical analysis in the area of many lah, okay, mathematics, okay, science, engineering, and technologies. All right. So the last is maybe you need to blend some, okay, research interest in the numerical solution of the fuzzy logic, for example, okay, delay equation, algebraic, artificial intelligence, all right, and then try to develop a new numerical method. Okay, so when you deal with the numerical method, okay, you deal with the skill, okay, scheme, and we deal with the variant, okay, of developing the method. All right, so in this case, okay, how to do the theoretical numerical analysis? So in this case, okay, when you finish, okay, develop the numerical analysis, we hope that the theoretical numerical analysis can associate with the data driven of your numerical method. Okay, how? Because we want to optimize, okay, the solution. All right. So in this case that I told you, you can have so many tools. Okay. For example, modeling, finite different method. Okay. Finite element, finite volume, or artificial intelligence. Okay. For example, machine learning or statistic approach compare with the data, exactly data. All right. So nowadays you can see, okay, it's not difficult to find the real data to do the verification and validation. Am I right? So we hope that there is a range, okay, between the pure maths and the numerical techniques. We try to close the range. Okay, we try to close the range. All right. So now, okay. Okay, so let's we go to the difference between what's when you do masters before in numerical analysis, you go through all this process. I know, all right? You produce the original piece of work, okay? You focus on the important theorem to be demonstrated, all right? And then the numerical application is accepted, all right? And then there is a meaningful numerical theory of the process based on the mathematical modeling, the theory you can transform to the numerical analysis, and then the result is very successful, and towards the end you can explain your result in many types of the performance indicator, for example in numerical or in the statistic approach or in the AI indicators and so on. Okay, it depends on your field. All right. So PhD is more specific. Okay, the aims is more to give a significant original contribute to one field. Okay, meaning that PhD is not multidisciplinary area. It's a one field. For example, I want to focus how the temperature behavior in this room based on the parameters. What is the model that I want to contribute? And then towards the end, what types of the discretization for the model and the mathematical modeling to support the discretization. So it's very focused. All right. So what we train you is to make sure that as a supervisor, as a professional researcher, all right, we want to train our PhD student to produce their own research. All right. There is a very far gap, after completing the PhD, and then they can go through for their future research. All right. And then the contribution, of course, to formalize the mathematical theory for mathematical methods. You have a theory and then use a numerical analysis, all right, and then develop the numerical methods. And if you deal with the AI, artificial intelligence, there is a theory, basic theory on the machine learning or deep learning, and then you do the classification, method, and then do the analysis, and then there is a clear application. Clear application means that we not apply mathematics to mathematics. We more on the applicable, real grand challenge application. Yeah. All right. So now, the first, for PhD student, we need to produce, a theorem and prove the theorem, and then we come up with a complex theory, of the mathematical modeling and numerical analysis. So this is your contribution, this is your originality, this is your novelty, all right? So next is a numerical result. The numerical result is more significant impact to the application, to the model, to the numerical method, and convincing, convincing and influence, to the application itself, all right? And then the result should be many angle, meaning that not just numerical analysis approach, but what is the field, what is the indicator performance to measure your field. For example, if you want to go for the industrial manufacturing, So what is the indicator for image? Okay, what is the indicator to show that the contour region that you develop is much more accurate with the existing contour line or the edge of the images. All right, so this is the difference between masters and PhD. So PhD, of course, the year is 5 to 7 years, and masters 1 to 2 years. All right, and then the chapters numbers also increase because it is too much deeper. All right, so it's sometimes include 7 chapters for PhD. So now we go to the numerical application. All right, so for numerical application, I love if I can share with you one of the here. All right, you can see here. I go to one website about the numerical method for biology and biomedical, because nowadays the application in this area is too many. So I go there and then I search what is the requirement. You can see here. This is a very hot topic nowadays. People want to solve the biological or biomedical problem with the solution using numerical. So they describe a complex and multi-physics flow problem. So in this case, what should you do? You go to the maybe mathematical modeling related on the flow. Maybe you need to go for the fluid mechanic. And then you need to go for some mathematical modeling related on the multi-physics. Maybe you need to have some support from the COMSOL multi-physics to visualize the environment parameters to solve the biomedical problem. All right, others is, you can see here. All right, there is a computational tool that you need. What is that? For example, to show the visualization, to do the big data simulation, you need to have a tool. Why? Because we want to improve the accuracy between the predictive model or numerical model and the exact solution. So in this case, you also emphasize a subsystems arising in application, for example, in the signal processing, other methods, because you need to do some research and more rigid, more accurate, more precise, and convincing. So that's why in numerical you can see, all right, there are many field that you can involve, all right, to make sure that your result is a good, all right, accurate, and so on. All right, so now we go to the application of numerical method. For me, because numerical is a root, all right. In my area is big data is a root, high performance computing is a root, for numerical analysis and numerical computational or computational science. So I give you some example. All right, so the early of my research, I'm doing a prediction of temperature behavior when we do the manufacturing wire. You know why wire? Because I start from one dimensional. I represent the very fine wire, for example, fiber optic, in one dimensional problem. So I can apply parabolic equation in one dimensional problem as a basic of my research. All right, so it depends on the diameter of the wire, and then I start collecting the parameters involved. All right, the second is 2D of the you call here is a tire tread, tire celup. Lorry always use a tire tread, because it's very cheap. All right, and then some car also they're using a tire tread. So how to develop a tire tread is very long. All right, very long with the some you can see a design of the tire tread. So how to do it? How to mold the tread? All right, and then how to do the compression modeling process of the tire tread. So this is depends on the 2D or 3D application. So I start doing some mathematical modeling using the partial differential equation to represent the process of molding for the tire tread. All right, and then since we are know how to convert from 1D, 2D, and 3D problem, so we start looking for the biomedical problem. For example, my early stage of research is finding how to detect the cancer growth, especially at the breast, breast or brain, or lumps or tumor, or lump, or proliferation and so on. So there are so many model to represent the tumor growth. One of them is hyperbolic equation. All right. And then some of them using parabolic equation, some of them using many of the represent the cancer's growth. Nowadays, people looking how the cell growth based on the nano cell approach, nanoparticle approach, when we inject with the nanoparticle, how to reduce the cell. All right. So this is a process that we can transform the images, get the age, and then find the parameters to see how the cell growth without treatment or with the treatment. All right. So there are so many applications. So we can write the what we call this one is research problem. Your research problem. Go to the second line. The quantitative example, the way how you write the problem. In numerical, we said that the purpose of this numerical analysis method using for example, you more detail using finite different method is to test the theory of the for example, Dick's theory or convolutional theory. All right, to relate with the some parameters involved. For example, if you deal with the tumor growth, you need to see the nutrition concentration, and then the blood flow, the density, then the temperature behavior, and so on. All right, so this is a control, what we call as a controllability variable, for your model. For what is your customer? Your customer is a patient. Sometimes the factories, to develop the wire, the good wire, without or remove or decreasing the rejected wire, for example, because the dimension is not in the specific quality control. All right, so the site is in our case maybe in the hospital, in the industry, in the using geoinformation system, using MRI images and so on. So it's very clear when you deal with the quantitative research, in writing the problem statement. Very clear. All right, so it's much more detailed and specific. It's not wide. It's not too wide area. Now let's we go for the writing a problem. There are statement that you need to highlight, and then there is an example in the green color. You can see here. The way you write a problem, of course, you never miss about the proposed solution. The problem is deal with. This is the writing. The way you write the problem statement. But the example, I go to my example. I sit here. What is ideal? I deal with the numerical method. Using the specific algorithm, all right, to get the approximation solution, converge to the exact solution. Exact solution, we can go for the data set, we can go to images, we can go to the bank of data. All right, we can go to the mathematical modeling proven by the specific journal, and then thus the method can be can be visualized the solution and making the decision accurately. So in sometime I'm using artificial intelligence, I'm using a machine learning method, so I can make the predictive model. All right, so almost the numerical method is a high cost computational. All right, so we need the improvement in terms of the computational cost, reduce the computational cost, reduce the speed, increase the speed of the computational, increase the performance of the accuracy in terms of what? There are so many ways. You can increase in terms of the higher order of your PDE, ODE, all right? You can increase using the real data, you are using a real data. All right, you can increase using the high performance computing. All right, Okay, so now to enhance the numerical method, okay, I'm using higher order derivative, all right, as alternative strategy for accurate prediction and simulation support by mathematical software tool. So since we are numerical, we cannot avoid from the doing programming, okay, doing the simulation, because we are the close gap between pure maths and the application all right. So now, okay, you can see here, okay, when you start answering the question, okay, when you start answering the question, okay, what is the question will address to you, okay, how you investigate the problem, okay, this is a issue, how you investigate the problem, all right. So in this case, there is specific, okay, answer, okay, to the question, all right. So means that you have a central phenomena of the variable to be explored, all right. What is a variable? Okay, independent, dependence, okay, mediatings or control variables, okay. So I'm focused on the controllability variables, okay, because okay, most of the application they are involve so many variables. So we go for the dominant variable, which is influence the real application. Yeah. So of course you cannot okay, run from these words. Okay, you can do as a describe, okay, model to describe the problem, to compare the method. So this is very important. In numerical, we need to do the comparison to indicate, okay, the research, okay, to indicate the research for studying. All right. So this is an indicator that you need to focus when you do the research question, and then this is a okay, way how we answer the research question in numerical method, okay, in numerical analysis. All right. So now here, okay, I love if we can use some words, very strong words, to represent the research objective. All right, we know the research objective for numerical analysis is to, okay, to find the solution, okay, using the numerical method, using a specific theory in numerical analysis. All right, so you can use the words, okay, the first objective is, of course, you govern the mathematical modeling. All right, you govern the mathematical modeling. The second is you discretize the mathematical modeling. All right, and then next you simulate using the some algorithm, maybe parallel or sequential algorithm, and then towards the end you analyze, okay, the result. I think 4 objectives is enough. All right, to visual is one of the indicator of the analyzing, okay, your result. All right, so this is very clear to describe the objective. All right, so because the objective should be specific, okay, logical, and have a time frame, okay, have a time frame. So okay, I'm love to use this word, especially for my student, you know, because we are very specific, okay, specific research. For example here, all right. So when we develop a mathematical modeling, for example here, one of my students using the multi-dimensional parabolic equation to represent the dehydration process, okay, food dehydration process. There are so many types of dehydration. Okay, one of them is a traditional, okay, using the temperature, and then the other one using the pressure and the temperature. So to increase the mathematical modeling, there are so many ways to do. The first is we think how to discretize the problem. Okay, if the model is too complex, we can go for finite element. If the model is very simple like this, you can go for the finite different method discretization. All right, so when we do the discretization, okay, we need to get a good result, very high accurate. So increase the order of derivative. Okay, when you use Taylor series, okay, you not use Taylor series order 1 or the 2. Maybe you can use order 3 or the 4, all right? And then when you deal with the numerical method, using finite different method, you start dealing with the point. Okay, sometimes we call nodes, sometimes we call grid, okay? All right, so we start using 5 point, 7 point, 9 point, 13 point as a sweat of the region. All right. And then maybe you can increase, okay, your research to convert from sequential algorithm that you are always use nowadays using MATLAB, Maple, Mathematica, Console, all right, and then Python and so on, to the parallel algorithm, because you deal with the big data, huge simulation, terabyte simulation, and so on. All right. So now, in numerical analysis, okay, we also, okay, focus on the indicator for numerical analysis should be proven for the specific application. For example, the consistency, the stability, the convergence, the preciseness, all right? So because we deal with the parameters is always changes, all right? Always changes. So when I deal with the, okay, specific mathematical modeling, I'm using, for example, here, execution time. I'm using the acceleration parameter, depends on the variance of the method. All right, I'm using weighted parameter theta. All right, and then I can change parameter with the specific, okay, method, whether this is explicit, semi-explicit, or implicit. All right, and then the computational cost, okay, dealing with the computational complexity and contribute to the runtime, All right, so now, okay, so since I know, okay, what should I do in the numerical analysis, what is the parameters, okay, so now I start developing the numerical method, the numerical scheme. Okay, numerical scheme in my case, okay, whether explicit, implicit, semi-explicit, hybrid, non-hybrid, there are so many terminology to express the scheme. All right, so this is one of the scheme, okay, we call as a Douglas, okay, double Douglas, okay, variance, we call as Bryan method. All right, this method is considered as numerical method. Okay, you can see there is a G1, G2, G3, meaning that this method able to run in the block, in the group. Okay, why I designed this method in the block, in the group? You know why? Because I can run this problem in the parallel, where I can send every block to a number of processor, a number of tasks, a number of grid, and so on. All right. So that's why, okay, there are so many ways to develop the numerical method nowadays, and people looking for the block method because the future ready system nowadays, supercomputer is distributed and shared in terms of the architecture. Okay, sometimes it's a hybrid combination between the distributed and shared memory architecture. That's why we love if we can convert the problem into a block system. All right, this is not block, so we can convert this into a block system. You can see most of the finite element method, okay, represent in the block system. All right, when we have a block system, okay, algorithm, okay, in sequential, you run using MATLAB, Console, Maple, okay, C, Python, TensorFlow, whatever. All right. So you need to have a platform. Okay. Maybe you are using laptop. Maybe you are using cloud. Okay. Maybe you are using supercomputer, cloud, and so on. All right. So there are so many future ready, okay, upgrade system, okay, to support your high performance computing system. In my case, okay, we have a distributed parallel computing system. We merge a number of computers to support the huge computational costs. All right. We also have the, okay, GPU, CPU architecture, all right, to support the large sparse, okay, simulation, all right, large sparse simulation. And then this is a time for us, okay, this is a time for us. If you feel that your problem is huge, involving terabyte, megabyte, okay, gigabyte, okay, and then repeating, okay, the iteration is repeat, so you need to wait, all right, and it involve a huge computational complexity problem. So what should you do? What should you do? So let's we try here. Okay, we try here. Okay, I hope I stop here. I can okay. All right, I can come you back. Okay, you try how to convert from sequential to parallel. I give you one. Okay, a few seconds. Right. All right. you can see here, okay, it's not easy. It's not easy because you are quite familiar with the sequential algorithm. It's not easy, all right, when you want to transform from the sequential algorithm to parallel, all right. Why? Because you don't have the platform, you don't have the ideas on transform from the sequential to the parallel, all right. And then people will say that why I need to solve a problem in the parallel algorithm. So this is a question. So for my answer is yes, you are dealing with the little, okay, maybe 10 point. Okay, after that, when you meet, okay, the huge application, you want to make a real, okay, simulation. So of course you need the high computational complexity simulation. So in this case, okay, you need the platform to support. Okay, you start finding the cloud or supercomputer, all right, to solve your problem. All right, so that's why, okay, you start looking, okay, transforming from sequential algorithm to parallel algorithm. All right, so in this case, okay, there is a communication between the processor, between the task, between the grid, and so on. All right, so now, when looking for the performance measurement and numerical analysis, okay, I told you, all right, so in numerical, we have the performance measurement, for example, error, okay, between the left solution and right solution. Sometimes we call as a residual error, okay, sometimes we call as a error estimation, all right, and then accuracy, how accurate between the data from the approximation solution and exact solution from images and so on. All right, so you start looking for the accuracy and preciseness. And then you start looking for the convergence if the method is iteration. Okay, its method is a iteration. So looking for the convergence and stability and consistency. All right. So when you deal with the parallel computing system, okay, when you deal with a big data simulation, there is another, okay, indicator. For example, the speed up, how much, okay, spend time for complete one process of the calculation, one process of the simulation, one process of the execution involving arithmetic operation, plus, minus, and other mathematical function, for example, cos, sinus, tangent, and so on. All right. And then efficiency, effectiveness, temporal performance, and granularity. So this is another side, okay, not involved in numerical analysis, but performance that you deal with in your research. You deal with in your research. All right. So now, okay, when you deal with the AI, okay, artificial intelligence, there is another performance, for example, okay, okay, consistency, stability, and so consistency, sensitivity, okay, specificity, and others. All right. When you deal with the numerical method, of course, okay, this is the traditional, okay, that you need to go through. The first is what? Errors, okay, error estimation, whether you want to use root mean square error, maximum error, okay, absolute error, and others. All right, from errors you can see which method is a champion, which is method is superior, which is a method is alternative to solve your mathematical modeling and your real application. All right, so this is the other indicator, for example, number of iteration to show the convergence, how fast the method converge to the exact solution. And then execution time, how much the method using arithmetic operation and the mathematical function to, okay, solve the problem. All right. And then this is a traditional indicator for the numerical method, but this is considered very important when you do the comparison. All right. So the other indicator, okay, to represent your performance of method, okay, when you deal with the classification of the machine learning, all right, so you do the indicator, for example, sensitivity, specificity, preciseness, okay, fall position rate, okay, and then fall positive rate, fall negative rate, all right, and then you can also visual the data of your solution in the 3D. This is very important, all right, because people can see which part, okay, which model is considered as accurate based on the indicator, okay, performance indicator and the data visualization, and put a rank. Okay, when the specific rank, the data is tumors. Okay, when the specific rank, the data is not tumors. All right, so you can visual in the colors here. Red color is a tumors, and green color is normal, is not tumors. So this is a process, okay, of numerical, okay, method, okay, to represent, okay, in our case is a classification method, okay, to represent the analysis. Okay, so this is your strength, because okay, you can compare the method. The important is you compare the method. There is a 1, 2, 3, 4, 5, 6, 7 method you compare, and then what is the optimum result? The optimum result is a straight line here. It's an optimum result. Shows that the IADE, okay, multi coloring is better from others. So the near to the maximum, the optimum is a better method. Okay, so this is alternative compared to the traditional method, Gauss-Seidel method, and then the what we call this one is a measure provider method, is a traditional method. All right, so you can explain more on the the method, the accuracy, the sensitivity, okay, the performance indicator of the method, all right, the stability, all right, and then convergence of the method, all right. So what is your contribution? You finding the superior of the numerical method by comparing with the some indicators. All right. Other indicator, when you deal with the supercomputer, a big data simulation, okay, or parallel computing, or you need to send a data to a number of processor. You have two computer here. You want to parallel the algorithm. There is another indicator that you need to investigate. What is that? Communication. Communication cost. How much you send a data, how much you receive the data, okay, and then the granularity, how much block you send for a specific task, okay, granularity, the ratio between the communication and the computational costs. All right, so try to get a good indicator when you develop the model, okay, and then develop the numerical solution. Okay, I love to go to my PhD student. Okay, here not a lecturer. After completing PhD with me, he is a data scientist in one of the investment company. All right. Okay, there are a few of my masters and PhD student now, okay, working as a data analyst and data scientist, because okay, they are dealing with the big data. All right. So now we go to the result. Okay, after using a machine learning. Okay, and then after getting one of the predictive model for brain tumor classification. All right, and segmentation. He is segmented or etched the MRI images for the specific region, okay, tumorous region, or we call there is lumps, okay, vascular area. All right, okay, we go to the see how they present. Okay, what is the product based on this disease? All right, so I'm stop sharing. If I can go to the all right, so I hope I can share here. Yes, I'm sharing. All right, so you can see here. Okay, during the presentation, okay, he is also presenting the result, okay, the process, but this is the outcome. What is the outcome? Okay, is the what we call as apps, okay, apps using MATLAB, just using MATLAB, okay. All right, so we can do a process, okay, by insert the images to the apps, and then we can detect the region, the area, okay, or the segment of the tumor, okay, of the tumor. When we use a number of images, okay, we can train the data that which is the tumorous and which is not tumorous. All right, so the process, of course, involving the pre-processing, all right, post-processing, feature extraction, okay, feature and then classification using a specific classification method. So we compare some classification method. Some of them, they are using k-means, all right, and schools shipping result, okay, post-processing. All right, we are using a manual segmentation, and then we increase the process of segmentation and so on. All right, so this is what we do. All right, So the process, okay, is much more convincing. All right, we demo the apps, okay, using the classification method. All right, and then you can see here how we highlight, okay, some numerical approach using a specific performance evaluation. All right, so now we go to the proposal. I know you have something in your mind. All right, you are something in your mind, but when you deal with a numerical, okay, analysis, I hope that, all right, you can grab the opportunity. All right, what is the opportunity? To solve the challenge of computational, okay, integral to the approach investigated and analyzed. So this is your aims, okay, to uh, okay, get a solution for the challenge in computational result, okay, integrating with the investigation process in your research, okay, and analyze your result. Of course, okay, what you do is developing the mathematical modeling, all right, and developing the numerical method, developing the algorithm, all right, analyze, implement on the specific hardware, apps or software, all right, and then do the analysis, okay. And then the other one is when you deal with the, okay, large scale, okay, simulation, of course you need to deal with the high performance computing, develop the algorithm, all right. And then if you deal with the AI, all right, so you need to have the process of training and testing the data. All right, you are using a specific performance analysis to the specific computational aspect. All right, so this is the topic that you can cover. Okay, I'm quite familiar with the conjugate gradient. Okay, last time we are using conjugate gradient because we don't have a high performance computing system. So we focus on developing a very distributed algorithm or block method we call as a conjugate gradient or preconditional method. Preconditional method is to enhance the existing method using specific weighted parameters or weighted or variant or variant. So people looking now delay or fuzzy logic or artificial intelligence approach, all right, to do the classification class and then dimensional reduction and so on. The important is, okay, you deal with the developing algorithm in numerical analysis to solve the grand challenge application, All right, so now we go to the scope, okay. When we deal with the scope, okay, how you, because numerical is very high scope, okay, especially when you deal with so many parameters, okay. For example, temperature in this room is depend on the, okay, the temperature itself, the volume of, okay, the volume of this room, all right, the flow characteristic, the velocity, density, okay, mungkin the evaporation and so on. So you need to have a very good characteristic, okay, for the specific application, all right. And then design or scale up in our case is a fluidized bits are vital to enhance the heat transfer. So you scale up, so meanings you if you want to dimensionalize between 0 and 1, if you want to scale up your experiment, okay, to the specific region, okay, you can do it, all right. And then you can transform to the discretization of the problem, all right. And then mix the characteristic, okay. Now there are so many features, okay, so maybe you need to use a mixing characteristic, all right. And then they are using a CFD technique, okay. Some of them, they are not using CFD, they are using other techniques, so you need to declare here. And then okay, because most of our problem is application, so we are always deal with the real, okay, dimensional, dealing with the real computing speed, okay, or numerical techniques, all right. So this is the you need to scale up, okay, with the laboratory skill, transform from the industry skill, all right. And then towards the end, you have to identify the trend and region and then the future trend in your research, okay. How to do that? All right, you can search from the Scopus or Web of Science to get the trend of your research, especially in the recent 5 years publication. All right. So now the next is what is a tool? So the tool here. All right. Since we are dealing with a numerical, there is a tool. All right. When I deal with a numerical analysis, okay, I need to have a modeling, simulation, and visualization tool. So of course, I'm using the open source or licensing software. Okay, if I deal with the open source software, I need to ask students to use Python, R, okay, or Scilab, or Keras or TensorFlow, all right. So or C++ or Linda, all right, or CUDA. If if the student have a problem with the open source because it's a traditional, it's a very heavy language, okay, so we ask them to use a MATLAB distributed computing, or COMSOL, or Mathematica, all right, or Maple, all right. So this depend on the how the student keep engaged with the specific tool. All right. In machine learning, okay, now my student go to others, software which is very important, open source, easy. If they go to the industry, they can work with the industry with the open source, for example, Keras, TensorFlow, Python, all right, and then Kimi and others. Okay, this is an open source support the correct what we call classification method, classification algorithm. All right. So now, okay, since let's go. All right. So this is other tool that you need to know. Okay, what's that? It's a platform. It's a platform. I know now you are at home. I'm here. So what should I do? I open my machine, okay, can be telnet from my student. So they can telnet from home, okay, they can share screen with me, and okay, they can telnet to the programming, and then they can run, and they can compile the programming at the, I'm using GPU, CPU architecture in the lab. All right. So before this, okay, they can go to the lab, okay, they can go to the distributed paracomputer system lab, all right. But here they can go for the telnet, okay, or ping from their specific region. All right, so this is no problem. Okay, even though if you don't have a platform, you can buy the memory and use a cloud computing. All right, so now how to do a research writing. Okay, I know your product is thesis. I know your product is what? Is a thesis. Okay. All right, with a master's PhD, okay, this is your product. So how to write your thesis, how to write the publication, how to write journal, all right? So the first thing, okay, when you start writing your thesis, okay, there are so many things you need to write. I know, okay, when you start, okay, keep engaged with a specific research, okay, you have so many, okay, ideas to write, okay. However, okay, please refer to your research scope. Okay, control your writing. All right. So, for example, one of my students, okay, they are using finite different. All right. So they know that this solution can be solved using finite volume method. All right. So that's why, okay, I asked him to specific which numerical method that he need to contribute. All right. It can be as a novelty of your thesis. All right. So they start engaged with the specific area, go to the next step, okay, to compare, okay, with the method. So this is to convince the external about your result. Okay, this is a process to compare with the result. All right, and then since my student, okay, you also start writing the paper. So the way how to write the thesis is much more very rigid, very static. Okay, for example here, okay, you transform from writing the paper. The paper is simple. Just write the abstract, introduce, okay, introduction, method that considered as your originality, the result, and conclusion. However, when you start writing the thesis, is more on the focus on the literature review. What is a model, and then what is the tool that you engage, okay, how you about your discussion. There is the references should be a recent publication. All right, so this is more rigid. All right, this is more rigid. So that's why I'm ask you to, okay, diagram, to do road map, of your writing thesis. All right. Sometimes, okay, you do like a puzzle, kan? Okay. So when you do a puzzle, okay, put in the sequence, okay, in the sequence in your file. All right. So now, how you do writing thesis from your research proposal. This is your research proposal. All right. Research proposal is start from the abstract, okay, introduction, maybe research proposal there is no abstract, maybe, okay, because you are still looking what you want to do, okay. So it depends on the specific university, okay. In UTM, I think there is an abstract, I think. All right. So there is a research question, literature review, research method, your aim of your contribution, detailed work, what is your plan, what is your schedule, what is your research plan, and then how to validate the method. All right. And then dissemination plan, okay, integration with other research activities and some references. So this is a table, okay, the content for the thesis structure. That's why sometimes your thesis in not 5 chapters, maybe 7, okay, maybe 6 or maybe 8 chapters, because it's full of your research process in doing the for example, here, your background information, the literature review, the conceptual, the method and material, the model that you contribute, the experiment development. In our case, we need the tool, apps, okay, software and hardware. All right, the validation in our case is a numerical result and analysis, and some the future work, okay, conclusion and future works. Okay, every chapters, okay, should have a summary. All right. So now this is one of writing, okay, abstract. It's full of the content, okay, full of content. Content of what? The research background, okay, the general problem, the research methodology, the way how to do the research implementation, the expected result, and the broader perspective. All right. For example, in my area, all right, in numerical analysis, I said that, okay, here, okay, you can see here, okay, people now, okay, can detect the cancer's growth not just using MRI, but they're using the nanoparticle, okay, or the nanotechnology to represent how the cell growth, and then how to reduce the cancer cell, all right, using the also, okay, nanoparticle based on the drug delivery to the targeted cell, for example, in the brain, in the, okay, specific region, all right, which is the dangerous area. All right, so we are using the injection, okay, nanoparticle injection or magnetic nanoparticle to bring the cell to the specific area. All right, so in this case, we're using the Navier-Stokes equation of the partial diffusion equation, and then because body, okay, the biomedical is a 3D, so we investigate how the drug delivery in 1-dimensional, 2-dimensional, and 3-dimensional partial diffusion equation. All right, so the methodology that we highlight here is developing the mathematical the numerical method based on the discretization of mathematical modeling using, in this case, they are using finite different method. All right, so the implementation, okay, we are using software. In this case, they are using the okay, they are using the, okay, high performance computing system. All right, high performance because there is a parallel algorithm of the AGE method. Okay, so they know that the method is superior, considered as a group explicit, we call as AGE. All right, and then the scheme that this research focus is a semi-implicit, full implicit, or full explicit. All right, the method that the focus is a alternating group explicit, red, black, Gauss-Seidel, and Jacobi method. So this is a process of the implementation. All right, so it's already contribute, I think, more, okay, half of your research time frame. All right, the expected result is what? Is a superior method, and then the broader perspective, okay, we hope that this method can visualize the process of the drug delivery, okay, using magnetic nanoparticle, okay, for the specific region, especially the very sensitive region, okay, brain or breast, okay, brain or breast. All right, so now this is one of the abstract. For introduction, okay, All right, you can write introduction many ways, okay, but in numerical, for me, I suggest you to okay, here. All right, okay, here, okay, you can see here. The first is develop, okay, where the problems come. Okay, in my case, I'm using nanofluid. All right, using a magnetic nanoparticle, okay, by the external magnetic field. Okay, how to bring the nanoparticle using the magnetic field from the specific region to other, okay, to other concentration drug concentration to the specific cell. All right, so in this case, okay, this is introduction. Okay, people know we put as a strong argument here. 2018 is considered latest. It's a recent 5 years publication. All right, the subtopic here is a drug delivery and drug release for the nanocarrier, and the specification and classification of the characterization nanoparticle as a skill nowadays. So meanings that to prevents from or to reduce the cancer's growth, we are using the drug delivery of nanoparticle. All right, the keywords, okay, the keywords here, for example, okay, anti-cancer drug classification, and then drug particle, drug material, controlling the release of the drug, okay, delivery, and so on. So this is a terminology that you need to highlight in this area, in the biomedical area. All right, the relevant, okay, the relevant is your area, your contribution is delivering, okay, delivering the numerical method. All right, the numerical analysis, okay, the theoretical of the drug delivery, and then the aim is what? Is the aim is you want to do the visualization. You want to do some control parameters impact the drug delivery of the nanoparticle to the specific cell. All right, and then what is the outline here? The outline, we want to focus on the how high performance computing used to speed up the process of the nano computing of the drug delivery. So this is our outline. So all in, we put in the one simple, okay, one simple introduction. All right. So what is a numerical result? I hope, okay, whatever you do, okay, you can do the visualization in 1D, 2D, 3D visualization. All right. So if you deal with the mathematical modeling, you can draw the graph, okay, you can draw the table, okay, and then you can draw the process getting the result. Okay, for example, here I'm drawing, if I'm using one-dimensional, how the computational molecule look like. If I'm using two-dimensional, how I arrange the grid, okay, the nodes, okay, and then how I do the group, okay, to send to a number of tasks, to a number of processor, to a number of grid. And then if 3D, okay, how I do the partitioning, or how I block the data, all right, how I decompose the data to a number of tasks. All right, so this is a very important, okay, to describe the process what you do, and then the result here. Okay, so from here there is a pro and cons. Okay, we want the result decreasing, but based on one method we call Luna, the graph is increasing. All right, so how you explain about this graph? Okay, but you can see that Luna is a worse method. Yes. Okay, all right. Okay, thank you very much. Okay, so this we already go to the, okay, almost the conclusion. All right, so how you explain the process, okay, the what we call Viet. Okay, the answer is Viet. All right, so now, okay, when okay, this is very important. When you deal with the online, okay, research here, you deal with the supervisor online, how you manage your file. Your file is a digital. Okay, so I'm using Trello here. All right, and then of course I just want to go to the, okay, important is okay, how you conduct research from home. Okay, you can scan, okay, using your handphone. Okay, you can answer the what is the important when you do the research at home. All right, because now your supervisor, is a virtual supervisor, is a remote supervising. So how you do the research from home, okay, especially in the new norm COVID-19 pandemic. All right. So now I love if I can go to the okay here. Okay, what is your when you do research, what is your aim? Of course, your aim is what? Is a job. Okay, job opportunity. You can see in numerical analysis, there are so many numerical related numerical job. Okay, for example, here I want to use this proven, meanings that when you do with this research, you can see there are very wide job spec in your career. All right, so I'm sharing with this last sharing. All right, you can see here. Before this, you can see most of the mathematician, numerical, they be lecturers, teachers. But now they change. The career is changed. Go to the data scientists and data analysts. All right, data scientists and data analysts. So that's why most of my students, they are working now not as a teachers or lecturers. They are working as a data scientist for undergraduate student and master student, and data scientists, for PhD student and master student. The range of their salary is very high. All right, it's very high, more than 3,500 per month. All right, so this is I think one of the encourage you to do research dealing with the numerical. All right, so now I come back to the conclusion, since we have the ends here. All right, when we deal with the conclusion, I just want to share with you, like, we go here. In the era COVID-19, we are lucky. We are lucky in numerical analysis research. Why? Because we are doing a transformation from the signal to digital research transformation. All right. So we can do a library research in terms of the literature review, in terms of the bibliography, but at the same time, we have a tool for the implementation and develop the methodology. The tool is a app, software, platform, all right, and then the and the hardware itself, all right. So the tool that we are using now is depends on you, whether open source or licensing. Licensing, you can go to the CICT UTM, you can go for the MATLAB console, you have the SPSS, and then you also have SAS. But if you go for the open source, is one of the opportunity for you to go for the demand in the industry. For example, you are using Scilab, Keras, R, Python, Octave, and so on. So this is open source where my student quite be easy to market, easy to employ, employable to the industry, to the company and so on, to the government sectors also. All right. So the performance evaluation nowadays not just focus on numerical but other field. If you want to integrate with the machine learning, if you want to integrate with the image processing, there is another performance evaluation indicator you need to focus. And then the second is a research collaboration. All right. Since we are in the pandemic, all individual research collaboration is important to leverage your future initiative with your supervisor. All right. And then, of course, this is a time for you to do the innovation, to do the contribution, for your research area, university, your career nowadays, is what? Data scientists and data analysts and the mankind, the human needs. We hope that research could be benefit to the mankind, to the people out there. So, I hope, I can end my, my presentation, all right, with the some sharing here. I hope I can send to your chat room. I can send to your chat room information related of the research aspect. All right, your research aspect. Go to the chat room. I go to your chat room now. Okay, I sent to everyone. All right. Okay, where you can click, just click and go to the video. All right. Thank you very much. Okay, send back to the Dr. Zarina as a moderator. Thank you, Doctor. You can get my presentation through the YouTube. Go to the chat link. Okay, click the first link. There is a okay presentation, my PowerPoint at the YouTube. Okay, I think in numerical, okay, since you keep sharing, okay, sharing knowledge with your supervisor using the video conferencing or keep engaged using a social media, I think you can make it okay in 4 years, okay. 3 years, I'm not sure. For me, 4 years is reasonable in numerical because the process of okay proving the theorem, do the implementation, okay, and then validate your solution. I think can be done. Okay, can be done. 3.5 years. All right, because it's how speed you screen sharing with your supervisor. All right. Yes, yes. Okay, and now I have a okay, almost okay, once a week I need to do 1 or 2 screen sharing with my masters and PhD student, especially students who are okay engaged to do a viva or proposal defense. So the important is okay how you keep engaged with your supervisor for the screen sharing. I know the material is a e-content, so in this case, I again, okay, I would like you to focus on how you manage your data because your data is a e-content. It's a digital. So I manage my file at the Trello here, all right, where I can put my student in the systematic in the system where everybody can access. All right. So this is one of the way how you manage. Okay, you easy to screen share with your supervisor. If not, okay, difficult because okay, you talk without action is very to investigate or validate, okay, or verify to assess, all right, the student performance, all right, achievement and so on. All right. Hmm. Okay, for my student, okay, for the proposal defense, I'm request them to present their preliminary result. At least the pioneer of the programming, at least Jacobi Gauss-Seidel, very pioneer, easy to get, okay, easy to get, and then easy to run, easy to implement. All right, why? Because they can see the overall process to be focused. For example, okay, they know the research methodology. Now, the next semesters after the research proposal defense is what? Is a running, okay, running the implementation. All right, so I think half of the time is a implementation. All right, because you have a strong methodology. And then to get a strong methodology in numerical research, you cannot refer to the very pioneer, okay, or very old, okay, references. Go to the latest 2007, 2017, 2018, 2019, 5 years, okay, 5 years recent publication. Why? Because numerical is very fast. Okay, the research in numerical is very fast compared to the pure math, statistics, and others. It's very fast. All right, now people looking for the smart city. How numerical can go for the smart city? Bitcoin. Okay, how the financial now go to the Bitcoin. All right, now people looking for the Internet of Things. Okay, not just finding the temperature behavior in this room using the thermometer, EEG, OEG, for example, okay, for brainwave and so on. There is another equipment, there is another approach. Now people looking for the what we call is automation, okay, smart, okay, everything smart. So that's why I'm always ask my student, go to the Scopus or web of science and control the citation and yes, all right, because you will get the new terminology, new ideas, new current, okay, or current research related on your real application. So for me, for doing a research proposal, okay, we need to have the pioneer result, okay, preliminary result. In statistics, for example, kan, all right, they need to do the not just there is a secondary and primary data. Go to the process from primary to secondary. So this is one of the confident level for our student. Okay, they can improve their confidence level and motivation to integrate with other contribution, originality, and novelty. That's we want. Am I right?